Welcome back to another video right here on FE Builds. I did tell you that we're going to do a build on this Traction Hobby. It was a bit slow at first, but we want to see what we can do. Either we're going to put an XR8 G3 in, G2 esc and G3 motor, or we're going to go for the Hobby Wing X3 2000 kV. Now I just quickly want to check what the programming settings are in this esc, and I've got my programming card over here. I've got a battery. I'm going to connect this, and I've also got the screen behind me, so I'll just call out the different settings. I've got the manual on my computer right behind the camera, so I'm going to switch this on and let's see what happens. And the power button is hiding far behind. Okay, there we go. Okay, and I'll show you. So the running mode is set to forward and reverse, and that's true. That was correct. That was what it was doing. The second setting, the battery type, LiPo, that's true. That's what I was running. The third setting, the cutoff voltage, was set at setting number 3, which is medium. And I would also do that if I put any brushless systems over here, just to protect my batteries. I'm not sponsored on batteries, and these batteries are quite pricey, so we don't want to damage batteries. Option number 4, the initial start force, was set to option 3, which is 4%. And I see over here it has 9 options, so let's just check the values that it goes through. Okay, we're not going to save that. It was set to 4% start force. The max forward force was set to 100%. The max reverse force was set to 50%, which is correct, as we can see over there. Number 7 is the max brake force, and that was set to 100%, which is option number 9. Number 8, the initial brake force, was set to 0, and you can change that all the way to 50%, I believe. It has got drag brake, and the drag brake was set to option number 7, which is 80%. That might explain why it was rolling back a couple of times on the video. And option number 10, drag brake rate. It's got 9 levels. It was on level 4. I usually set my motors on level 5. Option number 11, the neutral range, was set to 0.05 ms. Okay, the start mode punch was set to option number 5, and for level 5 punch I felt that it was a bit weak, but that might be because the starting force was set to quite low. Let's go to option number 13. PWM frequency was set to 8K, and the BEC voltage was set to 6 volts. This will be very important because I assume all these servos in here, from the small ones, especially the small ones, there's a chance that they might be a max of 6 volts, and putting them on 7.4 might just blow some of them off, so we don't want to do that. We don't want to be replacing servos. That's an expensive mission. So if we put another system in here, this is the benchmark. We're going to keep it on 6 volts. And the last option, option 15, is freewheeling, and that's currently disabled. So we've got the settings over here. I believe it goes back to number 1. So all the settings are saved on this video. Now we can go ahead and just take out this motor and see what sort of pinion is in there, and just get different measurements with the veneer, and see what other dimensions and everything. And this would be very helpful for someone who has bought this RC and wants to convert to brushless. And in case you're wondering, the signal wire goes on this side. As you can see, the white wire is on this side. Then you get the positive and then the negative towards the edge of the esc. So I'm just going to pull that off. Before we disconnect that pinion, before we disconnect anything, we're just going to do some measurements. I want to see where the screws that hold the motor are, the distance between them, and I also want to see the size of the shaft and just the overall dimensions of the motor. So we might lift the motor out, but we won't disconnect the pinion up until we need to. Okay, so I've got off the cover. There's some nice grease in there. That's good to see. It's got a plastic spur gear. You can hear the meshing. And there's specific settings on this orange plate over here for the different pinion sizes. So it is a metal pinion and it's a plastic spur gear, and it's got a clutch. Okay, so let's take this piece off and let's just look at it, get some dimensions, and just measure what's going on in there. Now, what I want to measure over here is if I can just get it out. Yeah, what I want to measure over here is the shaft size. The number of teeth, I believe that's 14. It's given in the manual. And the distance between the screws before I disconnect or touch anything. Because imagine taking all this out, disconnecting everything, and then finding out that we'll start with the screws. So that's a 30 millimeter screw spacing. Important to know. And the actual shaft itself, seems to be a 5 millimeter shaft. Now let's just quickly count the teeth just to make sure it's 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we got that. And let's just measure this motor. What is the diameter of this motor? Okay, so this is a 45 or 40, yeah, 45. What's the length of the motor? It is a 70. And I believe in the instructions it can take a maximum of a 46 wide motor and a 72 long motor. So I'm just going to set this motor down over here, and I'm quickly going to measure the motor that I've currently got and that we're going to put into test and see if that'll work. If that doesn't, then we'll put this back. The one thing that I don't want is cogging, but I'm also going to set the settings on that motor in such a way that there's not so much power initially, because these are BFG KO2 replicas, and I really like BFG KO2s. I've had them on many of my vehicles, and some people complain about them, some people don't like them. For me personally, they've worked really well, so I don't want to finish these. I don't want to run them down. When you put a brushless motor in, chances are we'll be doing a lot of dig outs, and these nice beautiful tires might get messed up, so I don't want that to happen. So let's go measure that other motor, and then I'll be right back. Okay, so we have soldered on the new motor. We've got it all set up. It's ready to go, but I have to take off this piece in order to fit it. So let's move the RC back so you can see what I'm doing. Then we'll pretty much be sorted. But right now what I want to do is just fit this in here and just get a gauge as to where the pinion needs to be. The tricky part is actually getting this mesh just right. So you don't want it too tight, you don't want it too loose. And usually the manufacturer's mesh is perfect, and hopefully we can get that. I actually use sound sometimes to mesh the gears, because sometimes using paper you don't get it exactly right. Sometimes you press the paper a bit too hard, so it's always good to listen to the meshing that the manufacturer sets and copy that meshing. So we've got the spur gear and the pinion perfectly aligned. Now we're going to connect this system up. To do that, we have to quickly open this receiver box, and once again I'm on the same mission, not to we need one size up, not to disconnect everything and unplug and unwire everything without first making sure. You can actually get a nice view of that receiver. Okay, so it's a Dumbo RC receiver. As you can see, the channels are all marked. Channel 2. So I'll be able to disconnect this here, taking note of the way the wires go. And on this there should be some indication of negative and positive, apart from that notch. There we go. I'm going to get all the wires out of the way of these gears that are moving over here, because we don't want any wires to get damaged. I'm going to lift the car up, plug a battery in, and power on the new system. See how much power it's got. Okay, so we've got the receiver, it's on. The tires are moving freely. I just suspended them on a box right here. And on the PC is the old settings for the old ESC. We'll pull up the new ones just now. But my main aim is that the system should work at very low speed. It hasn't been calibrated yet, granted, but let's just see what happens. Okay, to see that these are turning. Okay, so this hasn't been calibrated yet. We'll just turn it off. And let's get into the calibration mode. Press and hold this button, then power on. Neutral point is set. Full acceleration mode. Set. Full reverse mode is set. Okay, so let's try that again. This is in high gear. Put it into low gear. Okay, so a lot of settings will need to be done for this to work, but I'm keen to test it out and see what happens. Okay, so this is just a test. I haven't done any setting. So all I've done is zero the timing. I haven't done any settings whatsoever. This is currently in high gear. Let's put it in low gear. I want to try and climb over that section of the bicycle, the exercise bicycle. So obviously it doesn't have the same low-end control, but we're not yet done with the tuning. So this is halfway through. The ESC has just been installed, and I installed it on the front section over there because I don't plan on putting a winch. Sorry, this video has been all over the place, but I've got a 3D printer on my other desk. All my desks are full, there's other builds, so I had to use my computer desk over here. And I'm pretty happy with the meshing over here. So I'm gonna actually lock this down now. And let's go into the settings, and I'll sort of record the screen, I'll sort of record the final result I get with the settings. So the body's closing nicely with the ESC at the front of here. That's a good sign. And now we just need to fine tune the ESC. So now it's not brushed anymore, it's brushless. I'm going to try and stop on the hill and see if it rolls. This is one of the tests. I allowed for about 10% of coasting. Okay, now let's put it into high gear and just test the speed that it's got. The brake is still a bit too aggressive. That is only a fraction of the throttle. Can go very, very fast. I'll try a speed run now. Okay. And it's slows down in proportion. So it is morning, and we didn't end this episode of the nighttime video. I'm actually here, and it is just sunrise, and I've got what I call the Raging Bull. I was going to call this the Black Hawk, but I ran out of Black Hawk stickers, so we're going to call it the Raging Bull. As you know from this video, we've put in the XR8 Hobby Wing, the XR8 Pro G3, and this is the G2 esc and the G3 motor. So the motor over here is a bit smaller, it's got a bit more top end, but the main aim of this whole mission with the 14 tooth pinion is to see, with the tuning that we've done, can it handle hills. This is the best I can think of that's very accessible, that's quick. Otherwise I have to go quite far to actually find a proper hill for it to climb. But I'm counting on those roots to bring out any chugging, if anything, because obviously it is a brushless motor, and it is sensored, and it's got some good settings, but let's see if those settings work. So we're going to get into that right now. Okay, so we've got the Raging Bull over there, and let me just flip on all the lights so it looks nice on this video. There we go, they're all on, and 3 clicks to the right should turn on something else. Always make a mistake. Let's turn that off. I want the other lights. Three clicks to the right should turn on these lights. So we're going to do this climb, and let's see how it does. I'm going to flip it into low gear, because obviously you won't do a climb in high range. So currently it's in the grass, it's not chugging, and I'm not doing this video to prove anyone wrong or anything, but I am actually doing this as an experiment to see if an XR8 can be used in this type of vehicle. Okay, so now we're in a situation which calls for diff lock. Let's lock all the diffs, and let's see if it's going to come through. Might have to reverse a bit. There we go, and it's out. I'm going to unlock the diffs and just move up slightly. I need to be very careful where I'm stepping, because in this area there's a lot of puff adders and boom slangs. In other words, they're poisonous snakes, and you don't want to get bitten. But on purpose go over the root. Once again, we'll lock the diffs. We'll start by locking the front diff first, see if that makes a difference. Immediately it did. Let's lock the rear diff. And let's see. We'll be able to pull through. Okay, and we're through. I'm going to unlock both diffs now. I like to use my diffs on a need-to-use basis. I don't like to use them if they're not needed. I feel like sometimes diffs are cheating. There's also a nice place to test the drag brake. So let's see how this thing progresses and climbs. This is about a... Okay, we'll switch on all the diff locks because there's a lot of loose ground and twigs. This is about a, let's say a 20-degree incline. So it's not too hectic, but if there's any chugging, it should bring it out. to choose another line over there. I set the drag brake to 75%, and when I release the accelerator, immediately it brakes. Okay. Okay, so it climbed that nicely. Let's climb the last part of this. And I'll try and get you a clip from the front, because this little ramp over here is quite a steep one. Okay, so I'm just pressing the accelerator very lightly. Let me actually try and go very slow. Try and crawl this. And no, it's not in slow motion. So at that very low speed, there's slight cogging. You can barely hear it. Actually, I think it's just the gears moving. It's not even cogging. Because cogging, we all know cogging if you know brushless motors and racing RCs at slow speeds. So this one's not really doing that. And as I stand up here, I'm regretting not closing Optimus's door, because I have to go back down and close it because I want to try the other climb. So let's go do that quickly. Makes for a very nice trail truck. So we're going to do these 3 hill climbs. This one, this other one that I'm going to now. Let me flip it into high gear and just test if there's going to be any chugging over here. So this next hill, I'm going to climb in high gear. But it's got a lot more speed. You see, this would be the top speed in high gear with the brushed motor. But now I was just literally touching the tip of the accelerator and it was going. Okay, so the next hill climb. Let's see in high gear, does it have enough resistance to stop? I put a bit of coasting. So in high gear, you can see that 75% drag brake isn't enough. I'm not pressing anything. Finally came to a stop over there. Let's see if it'll roll down more. But a good test to see is, can it actually climb at a very slow speed in high gear without cogging. So I'm only just touching the accelerator right now. Let's go a bit closer so we can see and hear. Okay, so also in high gear, it's not cogging yet. You can see how slow I'm going, and this is high gear. It's the proof on the remote that lower top button is not illuminated, it's in high gear. Just for interest's sake, I want to try this hill, just a small section up here again in low gear. See if it's gonna roll or if the 75% drag brake will work. See that red light next to the wheel? Hidden far in front of the wheel. The wheel can't touch it. I actually checked that yesterday. That's the new on and off button. So what I want to see, obviously it doesn't have the control that a Fusion Pro would have. Going downhill, it's going to accelerate when you press the accelerator like a real car. It's not like a slow and controlled active FOC braking system. But let's try and turn and climb back up. Okay, so now the same test where it was rolling previously in high gear. Let's see if it'll roll in low gear. So I just let off, it releases. This is minimal throttle in low gear. Up that same hill, I'll let off, and it holds. I allowed for a certain percentage of coasting because of the new speed that we've got. You don't want this beautiful body just braking suddenly and flipping over. I don't want that. I love it so much, I actually don't want to destroy it. This is a shelf queen for me, so. Okay, so let's go down this hill and let's go back to the car. We're going to another hill and then we'll go to the pit so we can test it on high speed, and I just hope I don't roll it. So I'll get some footage of going down this hill. But while we're actually here, we can quickly test the sand, the dig outs in the sand, because the sand is just there. One issue with this place is there's so many twigs and things that get caught up in under the vehicle, especially when it's got such a low ground clearance, which for me is not an issue. I'm not complaining, but okay, so we've got some sand here. Let's switch to slow motion and then we'll put it into high gear. Okay, so now we're gonna drive it back and we'll take a shortcut through the twigs and the grass. Hopefully we can get back to Optimus. We're going down here and Optimus is just around the corner. Okay, so we're back in the car and just quickly wanted to show you the reason why I actually put the button in an accessible place. You know, sometimes you're at the track or a trail and you're not going far away, but you just quickly want to switch off and move to another location. The button's just there. Press it, goes off, and you can press the remote, and it's off. Perfect. Let's go check out the next location. Okay, so we're at the next hill. Let's do this climb. The low gear can go quite fast. Just before it got stuck there, I was thinking Deflock would come in handy on this hill. There's a lot of loose sand, especially with those tires. Very nice tires, I love them. But on RCs, they don't seem to perform on sand so well. Okay, so we managed to get out of that. Get a bit closer and get a front view. So as you can see over here, the sand is very loose and it hits something like this tree over here. All the tires are just going to spin. It's so loose. So I always come here. Okay, let's try and climb this. As you can see, it hit another tree branch. In areas like this, you need momentum. You need to turn those wheels and just sort of swim through it. Let's get a view from the front. The drag brake is holding nicely. Slowly but surely, I'm powering through. I'll have to take another route. Otherwise it's just heavy and the sand is not going to climb over there. Let's go the other way around. And I don't want to finish the whole battery here. I still want to get some high speed. Is holding point. Just let off the throttle and it's holding at the exact same point it was at. I'm going to zoom in again. Let's power through the rest of this obstacle. That's the nice thing about a brushless mountain. It's just tons of power to give and it keeps on giving. It's like a gift that keeps on giving. Good thing I stopped. I found out why it wasn't powering through. It's tangled in roots. So we're just going to sort this out and I'll be right back. There we go. Let us finish the climb that we started. brake is holding. Let's continue to climb the way to the top. And now, as you can see the brake flashing over there, I'm literally just touching the throttle. It's just crawling through. But then again, I must state that this build was not for rock crawling, so you don't need that precision of Fusion Pro. Even though I have a Fusion Pro just sitting there, I might put that in another build that I do in the future. Much as it just passes through the climb. I'm quite excited about this because, you see, this is not about proving anyone wrong or proving myself wrong. This is just doing experiments, and I myself really thought this motor wasn't going to work in this RC, but it seems to be working as far as I can check and see. Now we're going to try and control the descent just by releasing the accelerator. It applies brakes. So it's more of a realistic driving experience. It's not like a competition rock crawler. More of a trail runner. So as you can see, I'm going to go all the way down the hill, and let's come down, and then we'll do that speed run just across the road, and then we'll call it a day. Why you see it roll a bit when I press the accelerator and release is the settings that I've put allow it to coast slightly, which is good for high speed, not so good for climbing down hills, because when you press the accelerator it wants to coast that percentage that I set before the drag brake kicks in, and also the drag brake rate is a bit less so that when I'm going very fast with it I don't flip it over. But let's do this now. Let's flip it into high gear, cross the road, and actually, okay, that's high gear. And what we will do is turn on the lights. Okay, let's cross the road. Do a bit of a speed burn.
Traction.